Welcome to the deep dive. Today we're cracking open something that, well, it might seem a bit technical at first glance. The Rotorcraft Flight Manual, or RFM.
And its close cousin, the Pilot's Operating Handbook, the POH.
Right. Now, this isn't just some dry document you stick in a binder. It's actually a vital resource packed with info that's crucial for flying helicopters safely and, efficiently.
Exactly. If you're involved with rotorcraft in pretty much any way flying, maintenance, or maybe you just have a deep interest, getting a handle on the RFM isn't just like a regulatory box tick.
No.
No, it's really the key to understanding how that specific aircraft is supposed to be operated.
Okay, so think of this as maybe your shortcut to getting up to speed. We've gone through the sources on how these manuals are structured, what's inside, and we're pulling out the really important bits for you.
Yeah, our mission today is to kind of demystify the RFM. We want to turn it from this maybe intimidating document into the practical tool it's meant to be.
We're hoping for some of those aha moments,
Yeah.
where things click into place.
And actually, the backstory of these manuals is pretty interesting itself. It wasn't always so organized.
Oh, yeah.
Well, in the early days, it was a bit of a free-for-all. Each manufacturer kind of did their own thing.
They're inconsistent.
Very. Led to a real lack of consistency in what information was there, how it was presented. You can imagine the confusion.
Okay, let's unpack that. So the RFM wasn't always this standardized thing we see now.
Not at all, no. The big change really came with GAMA, the General Aviation Manufacturers Association. They introduced a specification for the Pilot's Operating Handbook, the POH.
Ah, GAMA.
Right, and that was a huge step. It brought in much-needed standardization, not just for airplanes, but for rotorcraft manuals, too.
And that standardization, it wasn't just about neatness, I assume.
Oh, definitely not. It significantly cut down the potential for human error when pilots move between different aircraft types. Because now, you could expect to find certain information in a certain place. It was like the industry agreeing on a universal language for these manuals.
Okay, so that's why we often hear RFM and POH used almost interchangeably.
Precisely. There is one key detail, though.
What's that?
If the main title on the cover says Pilot's Operating Handbook, it has to state right there on the title page that it is the FAA-approved Rotorcraft Flight Manual.
Got it. So POH can be like a nickname, but the official identity is still the RFM.
You got it. And like you said, this standardization makes switching between aircraft much, much smoother for pilots. They know the layout, they know where to look for critical stuff.
Makes total sense. So, okay, you make up an RFM. What's the general layout? How's all this vital info organized?
Right, so an FAA-approved RFM can have up to 10 sections. That's not counting the preliminary pages at the front. It's designed pretty logically, really.
10 sections. Sounds pretty thorough. What are they, typically?
Okay, you could find. Section 1, general information. 2, operating limitations. 3, emergency procedures, really important. 4, normal procedures. 5, performance. 6, weight and balance. 7, aircraft and systems description. 8, handling, servicing, and maintenance. And 9, supplements.
That's 9. What about the 10th?
Ah, good catch. The manufacturer has the option to include a 10th section on safety and operational tips. And sometimes you'll find an alphabetical index at the very back, too, also optional.
Okay, quite a package. And having that structure must make finding things way easier, especially if you're, under pressure.
Absolutely. And even before you hit Section 1, those preliminary pages, they've got some really crucial details, not just fluff.
More than just the table of contents, though.
Oh, yeah, considerably more. And here's where it gets, really specific. Each RFM is actually unique to one particular aircraft.
Wait, unique. So my RFM for Helicopter A isn't identical to your RFM for Helicopter B, even if it's the same model.
Exactly right. It contains the specifics, like what equipment is actually installed on that machine, and the precise weight and balance data for that specific serial number.
Wow, okay, that's a huge distinction.
It is, and that's why the title page must show the aircraft's serial number and its registration number if it doesn't have those.
Then it's just for general info.
Right. Good for studying, maybe, but absolutely not for operating that specific helicopter.
Makes sense. It's like a bespoke manual for that one airframe. What else is usually in those front pages?
Well, you'll definitely find a table of contents. That's your main roadmap. Some might have a log of changes or a revision page, super important for keeping things current.
Ah, tracking updates. Crucial.
Definitely. And the page numbering is usually section specific. So you'll see pages numbered like 1112, then 2122, and so on.
Okay.
And if it's a loose leaf binder style, you often get divider tabs for the sections. And the emergency procedures section often has a bright red tab.
For quick access in, well, an emergency.
Exactly. That little red tab, it's a small detail, but it could save vital seconds when things go wrong. Shows some real thought went into the usability, even in the physical design.
Yeah, that's smart. Okay, so let's dive into section 1. General information. What's in there? Sounds like the basics.
Pretty much. It gives you the fundamental description of the helicopter itself and its power plant, its engine. Often, you'll find a 3-view drawing.
Like blueprints.
Sort of, yeah. Shows key dimensions: overall length, width, the rotor diameter.
Why are those basic dimensions important enough to be right up front?
Well, think practically. As a pilot, you often need to judge if a landing spot is big enough, right? Or will it fit in the hangar?
Ah, right. Operational decisions based on physical size. Makes sense.
Exactly. Those dimensions are critical for making quick, informed decisions, sometimes literally on the fly.
Good point. Need to know if it'll fit. What else is in section 1?
Usually towards the end of the section, you'll find definitions for any special terms, abbreviations used in the manual, explanations of symbols you might see on charts or gauges.
The glossary, basically.
Yeah, pretty much. And sometimes manufacturers throw in handy conversion tables, metric to imperial, that sort of thing.
Okay, so section 1 sets the stage, gives you the basic stats and the language key for the rest of the manual. What about section 2? Operating limitations. This sounds like the rule book.
That's a great way to put it. This section has all the limits, things required by regulation, or things the manufacturer says are essential for safe operation. It covers the rotorcraft, the engine, the systems, the equipment, everything.
So what kinds of limits are we talking about here?
All sorts. Airspeed limits, altitude limits, rotor limits, power plant limits, including fuel and oil types and pressures. Also covers weight and loading distribution, and general flight limitations.
Okay.
Plus, this is where you find explanations for the markings on your instruments, the color codes on gauges, and basic placards you'll see in the cockpit.
Let's talk about those instrument markings. Green, red, yellow. What do they mean?
Good question. Green is generally your normal operating range. Go zone.
Safe territory.
Right. Red means stop. It's a maximum or minimum limit. You absolutely must not go beyond that red line. Risk of damage or worse.
And yellow.
Yellow is typically a caution range. Maybe you're approaching a limit, or it's a range you can operate in, but perhaps only for a limited time, or it's just not ideal, a transitional zone.
Got it. And airspeed limits, obviously super critical.
Absolutely. These are usually shown right on the airspeed indicator with those color arcs we just talked about, but they're also spelled out here in section 2, maybe on placards or in graphs.
That red line on the gauge itself.
That's VNE. Never exceed speed. Go past that, you risk literally damaging the structure of the aircraft. Very serious.
And the green arc.
Normal operating speed range, where you'll typically be flying.
Okay. And sometimes there's another marking, blue or crosshatched.
Yeah, sometimes you'll see a blue line or maybe a red crosshatched line. That usually indicates the maximum speed for auto rotation.
Auto rotation, that's the glide without engine power, right? Rotor spinning freely.
Exactly. Critical maneuver if the engine quits. And there might be other speed limits too, like a lower VNE if you fly with the doors off or if you're carrying an external load.
So it depends on configuration.
Right. The example in our source mentions, say, 0 to 130 knots for continuous operation, 130 knots absolute max, but maybe only 100 knots max for auto rotation. You have to know these numbers for your specific situation.
Makes sense. What about altitude? Are there limits on how high you can go?
Yep, altitude limits are in here too. Some helicopters have a maximum operating density altitude.
Density altitude, that's altitude adjusted for temperature and pressure,
Yeah.
right, affects performance.
Exactly. And sometimes that maximum density altitude can actually change depending on how heavy the helicopter is. Think of thin air at high altitudes. It affects both the rotor's lift and the engine's power.
Okay. And then limitations for the rotor system itself.
Correct. Rotor RPM is critical. Too slow, not enough lift, bye-bye flight,
Uh-oh.
too fast. You risk structural damage to the blades or the hub. So just like airspeed, there are minimum and maximum rotor RPMs.
Shown on a gauge, too.
Usually, yes. Often with a green arc for the normal range and red lines for the absolute min and max. And interestingly, the limits might be different for power on flight versus power off, or Auto-rotation.
How so?
Well, power on usually has a narrower green band. Sometimes there's even a yellow arc in there where you might get some vibrations or harmonics you want to avoid lingering in. But power off, in auto-rotation, you generally have a wider green range to work with.
Fascinating how precise it all is. What about the engine, the power plant limits?
Similar idea. Covers engine RPM range, limits on power output, safe operating temperatures, and crucially, the specific types and quantities of fuel and oil you must use.
Right. Using the wrong fuel could be disastrous.
Absolutely. And many engines, especially turbines, but some piston engines too, have different power ratings. There might be a maximum power setting, often shown with a yellow arc and a red line, that you can only use for a short time, like during takeoff.
A time limit.
Exactly. And then there's a maximum continuous power setting, usually at the top of the green arc, that you can use indefinitely.
I also recall reading about manifold pressure limitations. Is that related?
Yes. Manifold pressure is mainly for reciprocating piston engines. It basically measures the suction or vacuum in the engine's intake manifold, gives an idea of how much power the engine is developing.
So it has limits too.
Oh, yeah. There'll be a red line on the gauge for maximum power, maybe a yellow arc warning you're getting close to the engine's rated power limit. You might even see placards in the cockpit listing specific maximum MP readings for different situations, like takeoff or climb.
Okay, so we've got limits on speed, altitude, rotor, engine power. What about just how heavy the helicopter can be and where that weight is?
Yep, that's covered in Section 2 as well. Weight and loading distribution. It specifies the maximum certified weights, gross weight, maybe empty weight limits, and the allowable range for the center of gravity, the CG.
The balance point.
Exactly. Get the CG wrong, make it too nose heavy or tail heavy, and it can become unstable or even uncontrollable. This section tells you the limits and where the reference point, the datum, is for making those calculations.
But the actual math, the calculations, are somewhere else.
Right. The detailed procedures and maybe sample problems for calculating weight and balance are usually in Section 6. Section 2 just states the absolute limits.
Got it. And finally, within limitations, what about just things you can't do? Flight limitations.
Yeah, this covers prohibited maneuvers. Like, most helicopters aren't certified for aerobatic, so it'll say acrobatic flight prohibited.
Makes sense.
Or if the aircraft isn't equipped for it, it might say flight into known icing conditions prohibited. Big one. Also, if it's only certified for VFR visual flight rules, it'll state that limitation here.
No flying in clouds, then.
Correct. You might also find the minimum crew required, usually one pilot, but maybe two for some larger types or specific operations. And sometimes it specifies which seat the pilot must occupy for solo flight.
Oh, interesting. Left seat or right seat matters.
It can, yeah, depending on the helicopter's design and controls. And importantly, this section often really emphasizes the placards you see around the cockpit. Those aren't just suggestions, they're reminders of critical limitations. The VNE placard is a classic example.
So Section 2 is basically the thou shalt not chapter for safe flying. Next is Section 3, emergency procedures. Hopefully not used often, but vital.
Absolutely critical. This section gives you concise checklists, recommended procedures, key airspeeds for handling various emergencies.
Like what?
Engine failure, maybe different procedures depending on whether you're high up or down low.
Right.
Tail rotor failure, which is a big one for helicopters. Fires, system failures, maybe even procedures for trying to restart the engine in flight or ditching in water if you have to.
And are these checklists long and complicated?
They try to keep them clear and actionable. Often manufacturers will give you an abbreviated checklist first, just the immediate vital steps, the sequence of actions, memory items, basically.
Things you need to do right now.
Exactly. Then, that's usually followed by amplified procedures, which give more detail and explanation for each step, for when you have a moment more to think or confirm.
So the key is really learning those initial steps by heart.
Absolutely. In a real emergency, fumbling for the manual for the first few actions might waste critical time. You need to know the immediate actions instinctively.
Makes sense. Reaction time is everything.
It really is. And sometimes, especially in larger, more complex helicopters, there might be an optional section called abnormal procedures.
Different from emergency.
Yeah, this would cover malfunctions that aren't immediately catastrophic, but aren't normal either, and need specific handling.
Yeah.
Maybe a caution light comes on, but it's not an outright emergency yet.
Okay, good distinction. So moving from emergencies to the everyday, Section 4. Normal procedures. This must be the most used section.
You bet. This is the bread and butter of daily flying. It often starts with listing recommended airspeeds for normal operations, best climb speed, best approach speed, things that enhance safety and efficiency.
And then the checklists.
Loads of checklists. Covers everything from the pre-flight inspection before you even get in, to before starting checks, engine start, engaging the rotors, ground checks, takeoff procedures, climb, cruise approach, landing, and finally, engine shutdown and securing the aircraft.
The whole flight profile, step by step.
Exactly. Some RFMs even include procedures specifically for practicing things like auto rotations safely.
And the emphasis here is definitely on using the checklists, right? Not just knowing they exist.
Absolutely paramount.
Yeah.
It's so easy, especially when you're experienced, to think you remember everything. But checklists prevent complacency. They ensure you don't skip a critical step, especially during busy times like takeoff or landing. It's just fundamental good practice.
Right. Discipline. Okay, Section 5. Performance. This tells you what the helicopter can actually do under different conditions.
Precisely. This section contains all the performance data required by the regulations, plus often extra info the manufacturer provides to help you operate safely and know the aircraft's capabilities.
Now, is this data strictly a limitation, like in Section 2?
Not always, legally speaking, unless the helicopter is certified under stricter rules like Part 29 for transport category rotorcraft, where performance data is often limiting. But even if it's not a hard legal limit,
You'd be foolish to ignore it.
extremely foolish, yes. Operating outside the performance envelope described in Section 5 is, well, asking for trouble. It's the manufacturer telling you, here's what the machine can reliably and safely do under these conditions. Pushing beyond that is venturing into the unknown and potentially hazardous.
So pilots need to really consult this section for planning.
Absolutely. Before a flight, especially if it involves heavy loads, high altitudes, or hot temperatures, you need to determine the expected performance and make sure you stay within those parameters.
What kind of charts or data would you find here?
All sorts of useful stuff. Charts to convert between indicated airspeed and calibrated airspeed because the gauge isn't always perfectly accurate. Hovering ceiling charts are a big one.
Hovering seal.
Yeah, charts that tell you, based on your gross weight and the current density altitude, how high you can expect to be able to hover, either in ground effect, IGE, or out of ground effect, OGE.
Ah, okay. That seems incredibly useful for picking up loads or operating in confined areas.
Definitely. If the chart says you can't hover OGE at your planned weight and altitude, you might need to reduce weight or rethink the mission. You'll also find those height velocity diagrams here.
The dead man's curve. Sounds ominous.
It kind of is. It shows combinations of altitude and airspeed from which a safe landing might not be possible if the engine fails suddenly. It defines avoid zones, typically low and slow or high with insufficient airspeed for a good auto-rotation entry. Knowing that curve is critical for safety, especially during takeoff and landing phases.
Wow, okay. Lots of critical planning data in Section 5. Now, we've covered the first 5. Can you give us a quick rundown of the remaining sections 6 through 10?
Sure. Section 6, as we touched on, is weight and balance. All the official info needed to do the calculations, empty weight, arm moment data, maybe sample problems to walk you through it.
Essential for making sure it's loaded correctly.
Critical. Section 7 is aircraft and systems description. This gets into the details of how the various systems work, the engine, fuel system, electrical system, hydraulics, flight controls, etc. The depth can vary a lot depending on how complex the helicopter is.
More complex machine, more detail needed. Makes sense.
Right. Section 8 is handling, servicing, and maintenance. This outlines manufacturer-recommended maintenance, required inspections, maybe how to comply with airworthiness directives or ADs.
ADs are mandatory fixes or inspections, right?
Correct. It might also cover preventative maintenance pilots are allowed to do themselves and how to properly handle the aircraft on the ground, towing, mooring, that kind of thing.
Okay, Section 9.
Supplements. This is where information on optional equipment lives. Stuff that wasn't part of the basic helicopter certification but was added later. Maybe special radios, autopilot, floats, cargo hook, searchlight.
So add-ons.
Exactly. The info might come from the helicopter manufacturer or the equipment maker. The important thing is that this info needs to be integrated. You need to know how it affects limitations or procedures.
Got it. And that optional 10th section.
Section 10, safety and operational tips. If the manufacturer includes it, it's kind of a best practices section. Could cover anything from physiological factors affecting pilots, weather considerations, tips for fuel efficiency, specific warnings about things like external loads or low rotor RPM situations, maybe recommendations to help prevent emergencies. Basically, bonus wisdom from the designers.
Sounds like a potentially very valuable section, even if optional.
Definitely can be. So, wrapping up this tour through the sections, the big picture is clear. The RFM isn't just paperwork.
No, it's a carefully structured tool.
Exactly. Designed to boost flight safety by making sure pilots understand their specific machine, its capabilities, and just as importantly, its limitations.
Absolutely. So quick recap then. We've seen the RFM, or POH, evolve into this standardized, legally important document. It's packed with critical info for safely flying one specific helicopter. Getting familiar with its structure and content really empowers pilots, mechanics, anyone involved.
And hopefully for you listening, this deep dive has given you that shortcut, highlighting the key areas and maybe some surprising details within the RFM without, making your eyes glaze over.
Yeah, hopefully. And maybe a final thought to leave you with. Think about how truly understanding the RFM changes how a pilot relates to their aircraft. Does it move beyond just operating the controls to genuinely understanding its heartbeat, its boundaries, its real potential?
It's a deeper connection, perhaps.
Yeah, and it makes you wonder, what other seemingly dry technical manuals out there might actually hold some fascinating insights if we just took the time to really dig in? Something to ponder. Thanks for taking this deep dive with us.